electric dipole. Okay. Now, electric dipole, there were two charges. Now, this charge is minus Q and this charge is plus Q. See, this is dipole. Dipole means you have two poles, equal and opposite poles, separated by some distance. Separated by some distance. Let us take this is center of the dipole. Let us take the center of the dipole is O. From the center to this charge is minus Q. From the center to this plus Q, it is Q. Okay. So this is called as dipole, right? Equal and opposite charges. Okay. The line joining the negative charge to the positive charge of the dipole is called as a dipole axis. Okay. This we call it as a equatorial axis also. Okay. Axial axis. Okay. Now this one equatorial means perpendicular. Perpendicular bisector of the dipole is equatorial. Okay. Along the this is along the axis. Okay. Now we will discuss another important one that's called as electric dipole moment. Electric dipole moment. This electric dipole moment is denoted by P. Electric dipole moment. Electric dipole moment, this P bar is equal to charge into distance between the two charges. Okay, this minus Q and plus Q. Okay, that is nothing but 2L. Okay, so it is magnitude of charge into distance between the two charges. Okay, Q into 2L. Okay, so okay, and the direction is from negative charge to positive charge. The direction is negative to positive. Now you can write the unit. So this is charge. So this is coulomb and this is meter. So this is the SI unit for electric dipole moment. This coulomb meter is called as dB. Okay, denoted 1 dB. Yeah, 1 dB is equal to 3.3 into 10 power minus 30 coulomb meter. Okay. Now, see, this direction important, minus to plus and minus to plus. The direction is from minus to plus, and the dielectric dipole moment is product of a charge into distance of the between the two charges. Okay. Electric dipole, the region surrounding the stationary dipole will have electric field, right? Right. Yeah. Now, see, electric field. Now, what is the electric field due to a dipole? See, one of the question he will ask you is, there is a container. In this container, I placed a dipole, like minus Q plus Q. Okay. Now, what is the flux? Okay. What is the flux? If you use Gauss law, flux is equal to Q in by epsilon naught. Now Q in is minus Q plus Q will become 0. So flux will become 0 due to flux due to dipole from a closed surface is equal to 0. Okay. Now, okay. Now, intensity of the electric field on axial electric field. Next point is electric field electric field uh, electric field intensity on on axial position.
Yes, sir.
On axial position.
Yes,
Now
sir.
you take two charges. Two charges. Now this we are calling it as dipole. This
Yes,
is
sir.
minus q, and this is plus
Plus.
q, and that is the center of the dipole. Now
Yes, sir.
axial position means you have to place somewhere here, okay, on
Yes,
this
sir.
side or that side on the axis. This is
Yes,
a
sir.
dipole axis. The line joining the two charges is called as dipole axis.
Dipole
So if you
axis.
place it on the axis, then it is axial position.
Yes, sir.
Okay. Now here the electric field here, due to this one, this electric field will be in this direction.
Yes, sir.
This is due to plus q, and
Yes,
this one is because this distance is 2L. From here to here it is 2L.
yes, sir.
Okay. Right. Now the distance from the center, you have to always measure from the
Yes, sir.
center of the dipole. Okay.
Yes,
So from the center of the dipole to this one is say R.
yes,
Now we know that this is L. So from here to here, this is R minus L.
L. Yes, sir.
For this one, this is R plus L.
Of L. Yes,
Okay,
sir.
so the electric field value is different. Plus Q will be more.
Yes,
Minus. Okay, now this minus Q. This is test charge is positive. So it
yes,
will be
sir.
attracting in this direction. So this is E due to
E.
this minus Q. Okay,
Yes,
net effective field, if you calculate, we are going to get the net effective field E net we will get as 1 by 4 pi epsilon naught
yes,
2p 2p by
sir.
rq
Yes, yes, sir.
2p by
RQ.
rq.
Yes, sir.
Okay, so this is when this distance is bigger, when r is very much bigger than l, then
Yes,
we
sir.
get E net is equal to 1 by 4 pi epsilon naught 2p by r cube, or else simply put E net is equal to 2 times of kp
AP by RQ.
by r cube.
Yes, sir.
Okay, this
Yes, sir.
is directed from minus q to plus q.
Yes, sir.
Okay, now this
Yes.
is axial position. That is axial
Axial
position.
position.
Okay, you have to re- remember this.
Yes, sir.
Okay, then I will write electric field intensity
Intensity.
on
Equatorial
equatorial
position.
position.
Yes, sir.
Equatorial position means we have two charges. One is minus q, other one is
Plus
plus
Q.
q, and then you have the line joining these two, and this is 0. And here if you are considering a point which is perpendicular,
Yes,
okay,
yes,
then
sir.
what is the field at that point? Now you can see here, now this one, this is test charge is positive. So this electric field will be acting in this direction because
Attract.
this will be attracting in this direction,
Yes,
and this positive will be pushing in this direction, will be
yes, sir.
pushing in this direction. So the field, the resultant field, this will be pushing in that direction. So the resultant field is in this direction.
Yes, sir.
That is E net.
E net. Yes, sir.
You see this E net is opposite to the direction of dipole moment because the
Yes, sir.
dipole moment is q into 2l
Negative to
from negative to
positive.
positive.
Yes, sir.
So we write E net is equal to E
Net.
net for the equatorial position is equal to,
Yes, sir.
okay, now with this distance you take it as r.
R.
Then, okay, it's always distance from the center to the point where we are calculating, that distance is r.
R. Yes, sir.
Okay, E net is equal to Kp by Rq.
R cube. Yes, sir.
Okay, so it is uh, the the axial is 2 times that of equatorial. So this one I will
Yes,
write E
axial to
equatorial net equatorial is equal to Kp by Rq.
R cube. Yes, sir.
Okay, this is net axial is 2 Kp by
R
Rq.
cube. Yes, sir.
Okay. Now here in some books we write minus also
Minus.
because
Opposite. Opposite, sir.
because it denotes opposite direction. P is
Yes,
in
sir.
this direction, this is in this direction, as both are vectors we are writing minus.
Minus. Yes, sir.
Okay. So that is in axial position, equatorial position.
Position. Yes, sir.
Now we will discuss electric field at any position. Electric field at
Any position.
any general position. Now here this is minus q
Yes, sir.
and that is plus q, and here you have minus q to plus q like this,
Yes, sir.
and then at any general position, so this is O.
Yes, sir.
Okay, so if it is making an angle like here,
Yes, sir.
making an angle theta, okay,
Yes, sir.
then this obviously this will be attracting in this direction and this will be
Repel.
this will be repelling in this direction, so you will have the direction.
E
Okay,
net. Yes, sir.
yeah. Now then we write here the electric field at any position is equal to k is 1 by 4 pi epsilon naught
Yes, sir. P.
kp by rq. Okay, same as that of equatorial, and
Yes,
then
sir.
in brackets we will write root of 3 cos square theta plus 1.
Yes, sir.
Okay, so
Yes,
if you put equatorial, if you substitute equatorial means theta is equal to 90. If you put theta is equal to 90, this term will become 0. It will
0.
become Kp by
R
Rq.
cube.
Now,
Yes,
if it is axial means theta is equal to 0. Theta is 0 means this will become cos 0 is 1. So this
1.
will
1
become
plus
3
1,
plus
2.
1, 3. No, 3
3. Yes,
plus
sir.
1,
Yes, sir.
4.
4.
Root 4
Root
is
4.
2.
2.
So it will become 2 Kp
2
by
kb by
Rq.
R cube. Yes, sir.
Okay,
Yes, sir.
right. Then after field, I will write potential. Okay, potential. potential is VA is equal to along the axial potential along the axial position will be equal to along the axial position potential is Kp by R square.
R square.
Okay. P is dipole moment. R is the distance from the center of the dipole.
Yes, sir.
Okay. Right.
Sir, volume inverted.